All right, geometry, here we go. The last lesson in chapter 8, okay? Last lesson here. Still working with circles for this last lesson, and we're working on the application problems. So the real world problems, circles in context is what this lesson's called, okay? You shouldn't need your books open on this. If you want, you can have it out, but I have all the problems on here in the notes for you, okay? The big thing on each of these problems is drawing pictures, okay? If you can draw a picture of what's going on to accurately describe what's happening, that's going to be your best way to solve these problems, okay? So let's go ahead and let's read through this first one together, okay? It says on this first one, while the Earth's orbit path about the sun is slightly elliptical, it can be approximated by a circle with a radius of 93 million miles. Okay, so for part A, it's saying how far does the Earth travel in one orbit about the sun? That is, what is the approximate circumference of the Earth's path? So if we're thinking about the Earth going around the sun, we want to find that total distance that it's traveling. So let's draw a picture of that. I'm going to draw it off to the side here. So let's just draw a circle. And now they say it's not an exact circle, it's slightly elliptical. So it's just a model of this, okay? This is going to represent the sun, and then this is the Earth traveling around the sun with a radius of 93 million miles. Okay, that's how far away we are from the sun. Okay, so now if we think about that, we want to find how far does the Earth travel in one orbit around the sun. So we're going to find that total distance around the outside. So I want you guys to go ahead and think about what are we going to do to find that total distance. And then once you're done with that, go ahead and answer letter B. So I want you guys to pause the video here, take around, let's say 5 minutes, okay? That should be plenty of time to answer both A and B. So 5 minutes, ready, go. All right, let's go ahead and go over this. So hopefully you guys realized on this one, if we want to find the distance we're traveling around the sun in a year, that's going to be our circumference. So if you remember from yesterday, the circumference, it tells you there, circumference, so 2 pi r is the circumference. And we're given the 93 million miles, so all you have to do is plug in 93 million in for our radius, because that's the radius. Okay, so we're going to say, okay, circumference equals 2 pi times 93 million. Okay, plug that in. And then you can just type this into your calculator and see what you get. If you want to leave your answer in terms of pi, it's around 186 million pi miles. Okay. But we should probably get our decimal answer as well, because if we were doing a science presentation or something, we wouldn't say 186 million pi miles. We would say the exact number. So if we type that in our calculators, so if we do 186 million times pi, this is our number that we get. So 584,336,233. Let's round that up to 234 miles. Okay, so that's how far we travel in one lap around the sun. 584 million miles. Okay, so let's circle that. All right, now part B was asking us how fast is the Earth traveling in its orbit in space? Calculate your answer in miles per hour. Well, to make one lap around the sun, that's a full year, right? It takes 1 year to travel this distance. So we need to find miles per hour. Well, we already have the miles. Let's find how many hours there are in a year, because we want to go from miles per hour. Okay, so in 1 year, let's do that. So let's say this is going to be hours in a year. Okay, so we know 1 year. If you guys learned conversion of units, you might have learned train tracks, however you want to do that. Okay, I'm going to do it kind of like the train track method. Okay, in 1 year, let's convert that to days first. So in 1 year, there is 365 days. So what I just did there is I made a fraction in days per year. So now if I multiply this, the years cancel out and now we're in days. So 365 days. And now I want to know how many hours there are in 365 days. So I'm in days right now. So now I know in 1 day, I want to put that on the bottom so that it cancels. There are 24 hours. Okay, so now the days cancel, and now I'm going to be in hours. So I need to multiply this. So if we take 365 times 24, we get 8,760 hours. Okay, so now we're in hours, and now I want to know miles per hour. So I want to divide these two. Miles on top, hours on bottom. So you take 584,336,234 divided by 8,760 miles, or sorry, hours. And this will give us miles per hour. Okay, divide that in your calculator and you get approximately 66,705 miles per hour. That's how fast we're moving right now through space, flying through space at 66,705 miles per hour. And we're also rotating, so that's also adding some extra speed, okay, depending on the direction that we're rotating at a given time of day. Okay, we're either rotating with it or against it. It's kind of cool to think about, okay? We're flying through space right now, that fast. All right, moving on. Let's take a look at number 113. I want you guys to go ahead and read through this. It gives you a picture for you to use. Okay, think about, so read the question, think about what it's asking for, answer that one again, take another maybe 5 to 10 minutes, okay? So pause the video here, take 5 to 10 minutes, see if you guys can figure it out, work together, help each other out, and see what you get. Okay, go ahead. All right, so this one we're talking about a car's windshield wipers. So in a car windshield, we're talking about a sector of a circle. If you remember that vocab from yesterday, this is a sector of a circle. And it wants to know the area of the windshield that's wiped. And if you know a windshield wiper, it's got that extra space at the bottom that's not being wiped. So we just want to find the shaded area, okay? So a couple things we want to find here. And there's multiple different methods that you could use to do this. The method that I'm thinking right now is we can find the area of the whole circle and then the area of this tiny circle and then subtract them. Okay, and then we can just find whatever fraction of that this is. Okay, so let me draw a picture of what I'm talking about here. So if we draw this full circle here, and again, there's multiple ways you could do this, so you could have done a different method and gotten the same answer. So let's pretend that the windshield wiper went all the way around in a circle. Okay, it's wiping this section right here. Okay, if it went all the way around in a circle. Okay, and it's not wiping this center section right here. Okay, and we know that our inside radius here is 5 inches, and this is 15 inches. Okay, we know that. Okay, so I want to find this shaded region, and then at the end I want to take whatever fraction that is to find just the sector. Okay, so let's go ahead and show some work off to the side here. So my strategy here is going to be the portion of the window, which is 120 out of 360. That's what portion we've got here. And then I want to just find the shaded region. So I want to take the area of the outside circle, or the area of the whole circle, and I want to subtract that center part. So let's write that down. So area of whole circle minus area of small circle. Okay, so this part right here, this is going to give me the shaded area. Okay, and that's what I want. Okay, and I want this fraction of it. So let's write down the area of the whole circle. And if you think about the whole circle's radius, remember that's from the center to the outside, that's going to be a total distance of 20. Not just 15, not just 5, total distance of 20. So that area, remember area of a circle is pi r squared. So we want pi r squared. So if we take pi times our radius of 20, pi times 20 squared is what we're doing. Okay, that's the whole circle. And then the small circle is going to be a radius of 5. So we want to subtract pi times 5 squared. Okay, and then this fraction, 120 divided by 360, that reduces to 1/3. Because that is, we just want 1/3 of that full circle is what's being wiped there. So 1/3 of that circle. Okay. So let's calculate this and let's see what we get. And we'll have our answer. So 1/3, 20 squared is 400. So 400 pi. 5 squared is 25. So we get 25 pi. Okay. And if we reduce this some more, 400 minus 25, that's 375 pi. And then that's over 3. I'm just going to do that all at once there. So I'm multiplying by that 1/3 in that same step there. And then if you divide this by 3, that ends up being 125 pi square inches. Okay, but we want the decimal answer on this one because it's an actual square inch of space that we're finding. And if you take 125 times pi in your calculator, you get 392.7. So 392.7 square inches. There you go. So that is that shaded region right there. And like I said, there's multiple different ways you could have done that. You could have found, the area of the sector first, which is kind of what we did. Yeah, like I said, if you got the same answer, there's a few different ways you could have done that. All right, let's flip it over to the next page. All right, guys, and I feel bad that I'm not here on this day. This is one of my favorite problems, the grazing goat. It's kind of fun. Normally I would bring something in to kind of show you how this works, but unfortunately I'm not there. So it's kind of a fun problem. So let's go ahead and read through it. Go ahead and just do part A for this problem, and then we'll kind of go from there and see how we do. So just do part A. So pause the video here, read through the problem, Zoe the goat, tied to the corner of a barn. Read through that and just answer part A. Take about, 5 minutes. Okay, might need a little bit longer than that, but try 5 to start. Okay, go ahead. All right, here we go. So again, on each of these problems, guys, when it's an application problem, you want to start by drawing a picture. Okay, so Zoe the goat is tied to the corner of a 15 by 25 meter rectangular barn. So the first thing I'm going to do is I'm going to draw that rectangular barn. Okay, so if I draw that barn, it's a rectangle, and this is 15 meters by 25 meters. Okay, and Zoe is tied to the corner of the barn, and if the rope is a different length, Zoe's going to be able to cover a larger area of grass, right? So for this first example, we're going to say the rope is just 10 meters. Okay, so we're going to say it's a 10 meter long rope. Okay, so that's 10. And if it's 10 meters, Zoe's going to be able to kind of make this path around the barn like this, okay? Which, if you think about this, since this is a rectangular barn, this angle here is 90 degrees. So there is a 90-degree portion of grass that Zoe's not eating because that's not grass inside the barn, okay? So if we think about that circle, there's a 90-degree portion, which is 1/4 of that circle that Zoe is not eating, so that is not grass. Okay, the rest of it is all grass, which is 3/4 of a circle. Okay, so I don't want to find the full area of this circle. I want to find 3/4 of the area of the circle, and that's going to be the square footage that Zoe is allowed to graze. Okay, so let's go ahead and do that. I'm going to zoom back out here a little bit. So our formula for this is going to be 3/4 times the area of this circle. Okay. And again, the area of the circle is pi r squared. Okay, so we're going to say 3/4 times pi times our radius 10 squared. Okay, so if you type this all in your calculator, 10 squared is 100, times 3 is 300. 300 divided by 4 is 75. So 75 pi, I always multiply by pi at the very end. Okay, so 75 pi square meters. And if you type 75 pi in your calculator, you get 235.6. And there you go. Okay, that's if the rope was 10 meters long. Okay, next, I want you guys to try this out if the rope was 20 meters long. So now think about if we extended that rope to 20 meters, what is that going to change about our circle, and how much more square footage or square meter is this Zoe the goat going to be able to eat? Okay, so go ahead and draw a picture of this one. Go for 20 meters long. Again, take another 5 minutes for this one. Ready, go. All right, for this one, if we extended the rope, that's going to change our picture a little bit. Here's why. If you draw your rectangular barn, 15 meters by 25 meters. So if you pretend that you're Zoe, the goat, tied to the corner of this barn, if we extend that to 20 meters, now that changes it because this side of the barn is only 15 meters. So as Zoe the goat's kind of wandering around here, when she gets to this side of the barn, she has some extra rope. She goes past this 5 meters because 20 minus 15 is 5. So there's 5 meters excess of rope, and she can kind of wrap around the barn this portion right here. So this is a 5 meter, sorry about my handwriting there. So that's 5 meters, and she can wrap it a little bit more around the barn. Okay, same thing down here, except she's 5 meters short over here. Okay, so this problem's a little bit harder because now we have a 3/4 portion of a circle here, and then this is a 1/4 portion of that circle up there that we have to add in. There's a little bit extra grass that Zoe can get up there. Okay, so let's figure out what we're doing here. So we want 1/4 of the area of a circle with a radius of 5 meters. So let's write that off to the side. So 1/4 pi r squared, and our radius there is 5. Okay, so we want that. And then we want to add in this big 3/4 section because that's the same thing that was going on up here. Okay, except now our rope is 20 meters long. So now I want 3/4 pi times 20 squared. Okay, so this is our formula for this amount of grass. Okay, type that in your calculators. So this one, it ends up being 25 over 4 pi. And this one here, 400. So 20 squared is 400 divided by 4, that's 100. Times 3, that would be 100 pi. Okay, and then if you add this together, it doesn't really work out too nicely. Let's just go straight to the decimal answer. So if we did 25 divided by 4, that's 6.25, plus 100, and then we want to take that times, or sorry, that should be 300. That should be 300 there. So what was that? 106.25. We want to take that times pi. Okay, so we get, sorry, it was 306. 306.25 times pi. This is what we should get. So 962.1 square meters. Okay, there's our answer for that one. All right, there's one more last one. So take another 5 minutes here. Okay, pause the video. Try this out if it was 30 meters long. How's that going to change your picture? And try that out if it is 30 meters long. Okay, ready to go. All right, so hopefully you paused the video, tried this last one out. I have to draw this barn a little bit smaller here. Okay, so this one, if we have a 15 by 25 meter barn, and if we have a rope that's 30 meters, that's longer than both sides of the barn. So that means I'm going to extend 5 meters here, and I'm going to extend an extra 15 meters up here. Okay, so imagine your Zoe tied to this rope. The barn's going to stop the rope here, and she's going to be able to graze an extra 15 meter quarter of a circle there, and an extra 5 meter quarter of a circle here, and then this massive 3/4 of a circle when her rope is 30 meters. Okay, so it's going to look something like that. Sorry, the picture's not great. Okay, but that should be 3/4 of a circle. Here, I have a better picture on this one here. Okay, this is essentially what's going on here. There you go. So if you want to try your best to draw something like that, that's kind of what's happening. Okay, so now when we write our formula for this, we have 1/4 of a circle with a radius 15. So let's write that down. So 1/4 of pi r squared, so 15 squared, plus 1/4 with 5 radius, so plus 1/4 times pi times 5 squared, and then plus 3/4 of a circle with a radius of 30. Okay, there you go. And then you want to type all of this in your calculator. So this one, it's 225 divided by 4 pi plus 25/4 pi plus, this reduces to 675 pi. Okay, and now if you add all these together, that ends up being around 737.5 pi square meters. And if you type that in your calculator, you end up getting 2,316.9 square meters. There you go. Okay. All right. This part D, this one's kind of a tough one. If you want, you can try this one out. So if you want to pause the video here, you can end the video here. If any of you want to try this one out, go ahead and try it out. It says Zoe is happiest when she has 400 square meters to graze. What possible lengths of rope could be used? Okay, so you have to find what length of rope gives you exactly 400 square meters. So you can try that out. Okay. And then if you wanted the answer, I've got the answer here. Okay, so pause the video if you don't want to know the answer. Here's the answer coming up. Okay, so the rope would have to be greater than 13.3 meters. Okay, or equal to, if she wanted exactly 400 square meters. Okay, there you go. All right, guys. Awesome job. Keep up the good work. Tomorrow we're going to do the closure and team test, and test is going to be on Friday. Okay, so if you were struggling with anything from this chapter, what's really nice about this is that you guys have these videos on YouTube. You can just go to YouTube, Mr. Rustcamp's math class. You can find that on there. Look up the geometry videos from this entire chapter, and you can watch these, go back, replay stuff, and check on things that you missed. Okay. I should be coming back on Monday, so I'm excited to be back. Keep working hard. It's going to be worth it. Test is Friday. Okay. You guys got this.